Hello, grade 8 learners! This is Teacher Lei and welcome back to this channel. So this video presentation is all about graphing linear equations, a topic for the 6th week of the first quarter in Mathematics 8. So, what you need to know? So at the end of the lesson, you are expected to first, identify the three methods of graphing a linear equation. Second, graph a linear equation given any 2 points, x and y intercepts, and the slope and a point. Before we start, let us recall about the Cartesian plane, which is very important in graphing linear equations. So, what is the Cartesian plane again? Very good. The Cartesian plane consists of two perpendicular number lines intersecting at the origin. The position, direction, and distance of all points in the plane relative to the origin are given by its coordinates, which is the ordered pair in the form of x and y. So, the x-coordinate or abscissa of a point is its horizontal distance from the origin. The y-coordinate or the ordinate of a point is its vertical distance from the origin. Hence, divided the plane into 4 regions, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Then, we can describe any point of the plane using ordered pair of numbers. So, say for example, we have the ordered pair 4 and negative 3. So 4 and negative 3 is located at quadrant 4 as it can be seen in the Cartesian plane. By the way, what is a linear equation in two variables? A linear equation in two variables is a first-degree polynomial equation. It can be written in the form of ax plus by equals c, which is the standard form, or y equals mx plus b, which is the slope-intercept form, where a, b, and c are real numbers and a and b are not equal to 0. So, what is the graph of a linear equation? So, the graph of a linear equation is a line. And graphing linear equations can be done using any of the three methods. First, using any 2 points on the line. Second, using x and y intercepts. And third, using the slope and the point. So, what is a graph? So, a graph is a visual representation of the elements paired together through the use of a coordinate system. So, one method of graphing a linear equation is using any 2 points. So what are the steps in graphing linear equations using any 2 points? So first, find at least 2 solutions of the equation. Remember that 2 points are enough to draw the graph of a linear equation. As stated in the line postulate, 2 points determine a line. Second, we're going to plot the solutions as points in the rectangular coordinate system. And third, we're going to connect the points to form a straight line. Let's try example number 1. We're going to graph the linear equation y is equal to 2x plus 1 using any 2 points. So what are we going to do first? We're going to find at least 2 solutions of the equation. So how are we going to do it? So we're going to assign any values for x, say 0 and 1, then solve for the corresponding value of y. So by substitution, when x is equal to 0, the equation y equals 2x plus 1 becomes y is equal to 2 times 0 plus 1. So 2 times 0 is 0 plus 1. So 0 plus 1 is equal to 1. So we have y is equal to 1. Thus we have the ordered pair 0 for the value of x and 1 for the value of y. So we have 0 and 1. For x equals 1, the equation becomes y is equal to 2 times 1 plus 1. So 2 times 1 is 2. Bring down 1, so 2 plus 1 is equal to 3. So the obtained value for y is 3. Thus we have the ordered pair 1 and 3. So the solutions obtained implies that if x is equal to 0, then y is equal to 1. Also, if x is equal to 1, then y is equal to 3. Thus, we have the ordered pairs 0 and 1 and 1 and 3 respectively. So what does this mean? This means that the line passes through these points, and now let us plot these points and draw a line through them. So how are we going to plot 0 and 1? So in here, since the abscissa is 0, it is 1 unit above the x-axis, so the point is located on the y-axis. For 1 and 3, starting from the origin, the point is 1 unit to the right of the y-axis and 3 units above the x-axis, so we have the point 1 and 3. And now we're going to connect the 2 points, so we have the straight line, which is now the graph of y equals 2x plus 1. Another way of graphing a linear equation is by using the x-intercept and the y-intercept. So what is that x-intercept? So the x-intercept is the abscissa of the point where the graph or line crosses the x-axis. So therefore, the point is on the x-axis and the ordinate is 0. So therefore, we have the ordered pair x and 0. How about the y-intercept? So the y-intercept is the ordinate of the point where the graph or line crosses the y-axis. So here, the point is on the y-axis and the abscissa is 0. So therefore, we have the ordered pair 0 and y. So since we are using the x-axis and the y-axis, so to represent the x-intercept, we also use x as the abscissa, and for the y-intercept, we are using y as the ordinate for easy identification. So what are the steps in graphing a linear equation using the x and y intercept? So first, we're going to solve the x and y intercepts by letting y equal 0 and x equal 0 respectively. Second, plot the x and y intercepts on the Cartesian plane. And third, connect the points to form a straight line. Say for example, we're going to graph the linear equation y equals 2x plus 1 using the x-intercept and the y-intercept. So to find the x-intercept of the given equation, let y equal 0, then solve for x. And to find the y-intercept, we're going to let x equal 0, then solve for y. So letting y equal 0, the equation y equals 2x plus 1 becomes 0 is equal to 2x plus 1 by substitution. Then next, we're going to eliminate 2x on the right side of the equation by applying the addition property of equality. So we have negative 2x equals 1. Next, we're going to eliminate the numerical coefficient of 2x. So we're going to multiply negative 1/2 to both sides of the equation by the multiplication property of equality. So negative 1/2 times negative 2x is x, and negative 1/2 times 1 is negative 1/2, and negative 1/2 is now the x-intercept, and the point is on the x-axis. So therefore, we have the ordered pair negative 1/2 and 0. Next, we're going to let x equal 0 to solve for y. So the equation y equals 2x plus 1 becomes y is equal to 2 times 0 plus 1 by substitution. So 2 times 0 is equal to 0 plus 1 by the identity property for addition. So 0 plus 1 is equal to 1. So 1 is now the y-intercept, and the point is on the y-axis. So we have the ordered pair 0 and 1. Now, we're going to plot the x and y-intercept on the Cartesian plane. So how do we plot negative 1/2 on the Cartesian plane? So since x is equal to negative 1/2, we have the ordered pair negative 1/2 and 0. So starting from the origin, move 1/2 unit to the left of the y-axis, and the point is located on the x-axis. For y is equal to 1, which is the y-intercept, so we have the ordered pair 0 and 1. So starting from the origin, the point is 1 unit above the x-axis. So the point is located on the y-axis. And then next, we're going to connect the 2 points. So we have the graph of y equals 2x plus 1. Another way of graphing a linear equation is by using the slope and the point. So, what are the steps in graphing a linear equation using the slope and a point? So first, express the equation in slope-intercept form, y equals mx plus b. Second, we're going to plot the y-intercept in the form of 0b or 0y. Third, starting from the y-intercept, use the rise and run in locating a second point. So take note, if the rise is less than 0 or negative, we move downward from the first point to look for the second point. And for number 2, if the rise is greater than 0 or positive, we move upward from the first point to look for the second point. And third, a negative rational number. Say for example, we have negative 1/2. This can be written as either negative 1 over 2 or 1 over negative 2, but not negative 1 over negative 2. And last step, we're going to draw a line by connecting the 2 points. Say for example, we're going to graph the linear equation y equals 2x plus 1 using the slope and a point. So what are we going to do? So the linear equation is in slope-intercept form, y equals mx plus b. So the slope is 2, that means 2 over 1, or the rise is equal to 2 and the run is equal to 1. And the y-intercept is 1, so we're going to plot 0, 1 on the y-axis. Then next, using the y-intercept, which is y equals 1 as the starting point, we move 2 units upward since rise is equal to positive 2 and 1 unit to the right since run is equal to 1. So we have the point 0, 1, and for the second point we have 1 and 3. And connecting the 2 points, we have a straight line which is the graph of y equals 2x plus 1. Another example, we're going to graph the linear equation y equals negative 3 halves x plus 4. So what are we going to do first? We're going to identify the slope. So the rise is negative 3 and the run is 2. And for the y-intercept, we have 4. Next step, we're going to plot 0 and 4 on the y-axis since the y-intercept is 4. So next step, using the y-intercept as the starting point, we're going to count 3 units down since rise equals negative 3 and 2 units to the right since the run equals 2. And then we're going to plot the second point and it has a coordinate of 2 and 1. Next step is to connect the 2 points. So we have a straight line which is the graph of y equals negative 3 halves x plus 4. Now, let's proceed to our first activity. So choose the letter of the correct answer and write them on your answer sheet. So question number 1. Which of the following is true about the graph of a linear equation? Letter A, it is a line. Letter B, it is an ellipse. Letter C, it is a parabola. And letter D, it is a hyperbola. And you have 5 seconds to answer the question. Time's up. The correct answer is letter A, it is a line, and you are correct. Question number 2. Which among the choices is the abscissa of a point? A, X-intercept, B, X-coordinate, letter C, Y-intercept, and letter D, Y-coordinate. You have 5 seconds to answer the question. Time's up. The correct answer is letter B, X-coordinate, and you are correct. Question number 3. What are the intercepts of the linear equation whose graph is shown on the right? A, X-intercept is 3 and Y-intercept is 5. Letter B, X-intercept is 5 and Y-intercept is 3. Letter C, X-intercept is negative 3 and Y-intercept is negative 5. Or letter D, X-intercept is negative 5 and Y-intercept is negative 3. And you have 5 seconds to answer the question. Time's up. The correct answer is letter A. The X-intercept is 3 and Y-intercept is 5. Question number 4. Which of the following shows the graph of the equation x plus y equals negative 3? So you have 10 seconds to answer the question. Time's up. The correct answer is letter A. The X-intercept is negative 3 and the Y-intercept is also negative 3. And you are correct. Question number 5. Which of the following shows the graph of a line whose slope is negative 2 and contains the point 4 and negative 1? So you have 10 seconds to answer the question. Time's up. The correct answer is letter D. And you are correct. So, how many items did you get? Great! Well, that's all for today about graphing linear equations. I hope you learned something. Thank you for watching. God bless everyone.